This video is part of our upcoming course on C++20, which is going to start from the beginning all the way to advanced things, all explained in plain English. We're going to cover C++ from the absolute beginning, so no experience is required. And we're going to go all the way to pretty advanced things. And we're going to cover all the big features of C++20, including the concepts. We're going to cover the three-way comparison operator. And towards the end, we're going to cover ranges, modules, and coroutines. We're going to learn all these things. If you are watching this in the future, please check the link in the description below. You're going to find the link to the course and watch it if you really are interested. In this lecture, we're going to see that sometimes you need to set up your own custom equality operator, especially if the default one generated by the compiler doesn't suit your needs. And we are going to look at an example. Suppose we have the point class here, and it has two member variables like we have been doing all along, mx and my, which are of double type, but we want to compare points based on the length method here. So the point with a larger length is going to be greater than the other. This is the design that we want to follow. So if our points are laid out in a Cartesian coordinate system, and we have a point here, for example, and we have another point at this location, the second point here is going to have a larger or longer distance from the origin point. So we're going to say that this point here is greater than the one we have to the right here. This is the logic we want to set up for our class here. So obviously the default compiler generated equals operator is not going to suit our needs because the default one is just going to do lexicographical member-wise comparison, and that's not what we want. So in this case, we need to set up our own equals operator. So the way we set it up is nothing new. We're going to use the same syntax we know, but notice that we do it as a member function. And after we set it up, we're going to implement it and use the length method to compare point objects. So in this case, we are comparing the current point that implements this operator to the point we have in our parameter here. We're going to say this length equals to the other length, and this is how we're going to compare the points and make sure that they are equal. And we're going to return true if they are equal. If they are not equal, this method is going to return false. But notice what happens if we try to use these methods in the main CPP file. We're going to set up 2 point objects, point 1 and point P2, and we're going to compare them. You're going to see that we are using the equals operator here, and this is going to work. This is nothing new, but notice that the not equals operator is also going to work here. Again, the compiler is going to look at the equals member function and use that to generate a not equals operator using our own custom equals operator, and this is really cool. Another thing you should notice is that implicit conversions are also going to work, and if we happen to have a literal in the first position, the compiler is also going to flip things around and call our operator on the object that it will have put to the left, and this is really cool. Again, the compiler is going to be reusing the rewrite rules that we have really learned about. If we have A equals B, the compiler can rewrite this as B equals A if this happens to help the compiler figure things out. If we have A not equals B in our code, the compiler may rewrite this as not A equals B or as not B equals A, depending on what the compiler really wants to achieve, and this is really cool. Again, notice that there is no need to do this operator as a non-member freestanding global function because a member implementation is really easy to follow, and the compiler is going to reuse this to even make implicit conversions work for the first operand, as we have seen in our code here, and this is really cool. So again, for this line here, the compiler is going to flip things around and then call the operator equals on the point 1 object, and we're going to get the same result that we expect here. And this is really cool. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is Custom Equality Operator. We're going to grab our template files and put them in place. And we are going to open this bad boy in Visual Studio Code by dragging and dropping here. This is going to give us our main CPP file that we can clean up a little bit. And we're going to set up our point class. I am going to put in the header and CPP file. Let's say point.h for the header and point.cpp for the implementation file. I am going to grab the code I have lying around on my drive for the point class here and reuse that in this example. We are going to have our include guards n, and we're going to have our class declaration here, all the class definition. And you don't really have to type all this. You can just use the code from the resource section of this lecture here. You can download the code and reuse it if you don't want to type all these things. But I encourage you to really type this, because if you are a beginner, this is going to help you grab these things and really understand them. So we have our point class. We have a bunch of constructors here. And before we look at the constructors, we should really look at the member variables that we have. We have two member variables, mx and my, and the constructors are basically going to forward the data to be stored in our member variables. We have a default constructor, which is not really going to do anything. It's going to leave the member variables as is. We have a constructor, which is going to take two parameters, x and y, and forward those in our member variables using an initializer list that we have here. And we have a constructor taking one parameter, and it is also going to forward the data to our member variables. But this constructor should really delegate to the other one. So what I am going to do is put that last, and we're going to make it delegate the construction work to the constructor that takes two parameters. I think this is going to be much cleaner. So we're going to say point, and we're going to pass xy and xy, and this is going to do what we want. And we're going to put a body. I think this is what the compiler wants. And we can use braces here. This is going to be consistent with what we have on top. And this is really cool. Okay, so, but what we want to look at is our equals operator. You can see that it is not defaulted because we want to compare points based on the length. If we hop over to the CPP file, we can put in our implementation code, which is going to include CMath because we need to use the square root function here. We're also going to include the point header, and then we're going to implement our equals operator and compare points based on the length. This is really cool. Notice that we have the not equals operator commented out because this is going to be generated by the compiler. But what the compiler is going to generate is going to reuse the equals operator. And I just want you to see this and see that it is going to work, and really stress the fact that the compiler is going to reuse our equals operator and set up a not equals operator. This is really all I have to do here. I don't think there is any more to explain. We also have a stream output operator, which is going to print our points if we happen to need that. We can hop over to the main CPP file and include our point class. Let's do that. And then we can go in our main function and set up point objects and play with them and try to compare them. We can call the equals operator because we have it put in. That's going to work. And before we run the code, I think we should also adapt our stream output operator and make sure it also prints the length to make it really clear which point is greater than other points. I am going to move this to the next line and say length. And I am going to put out the length. I am going to say p and say length. We're going to call this member function. And this is going to do what we want. So in the main function, we should come and say point one. We can say that. We're going to say stdc out and say point one. And we're going to put that out. And we're going to say stdc out and put out point two. And our stream output operator is going to be picked up by the compiler, and it is going to print the distances here, and we're going to see them printed out on our PowerShell window. So we compare 2 points using the equals operator. This is going to say that they are not equal because the distances are going to be clearly different. The not equals operator is going to give us a true because they are not equal. We can compare to 10.5. And what this is going to do, the compiler is going to see that it can't call an operator on a literal. It is going to flip things around and then call the operator on 0.1. And then we're going to do an implicit conversion for the second operand, and the constructor that takes one parameter is going to be picked up and used to build a point object with the data that we have supplied here. So we're going to be comparing a point with 10.5n to a point with 10n. So the first one is going to be greater, and we're going to see that these two are not equal. And if we pass a point object in the first position, this is going to work because the compiler is just going to call the not equals operator on our object, and this is going to compare stuff. Let's try and build this with GCC. You can really use any compiler that supports C++20, but GCC is our favorite here. So we're going to use that. Let's bring up a PowerShell window and run Rooster. We're going to see our output here. We're going to see the length. These things are cramped here. I don't really like this, so I am going to go back in my stream output operator and put a space before length, and I am going to build again. Let's use GCC, and we're going to clear. Let's make sure we clear properly, and we're going to run Rooster, and we're going to have our information here. 0.1 equals to 0.2, that's going to be false because the distances or the lengths are not the same. 0.1 is not equal to 0.2, that's going to be true. 10.5 equals 0.1, that's going to be false, and 0.1 equals 10.5. This is also going to be false. Our operators are working. Again, notice that we just put in an equals operator, but the compiler is going to set up a not equals operator for us, and we're going to be able to use that in the main CPP file, and this is really cool. This is really all I had to share in this lecture, showing you that sometimes the default equality operator is not going to work for you, and if that's the case, you need to overload your own equals operator and implement it however you want to suit your needs. We are going to stop here in this lecture. In the next one, we are actually going to use the Spaceship operator in default mode, and that's going to allow us to compare using the greater than operator, the less than operator, and the equals versions of these operators, and this is really cool. Go ahead and finish up here and meet me in the next lecture.